Have you ever pondered how the universe as we observe it today came into being? How did the elementary particles that make up everything around us form? Our universe is a complex tapestry woven from the threads of cosmic evolution and the formation of these minute building blocks. From the galaxies that light up the night sky to the air we breathe, everything is a product of these particles. The story of the universe is the story of these elementary particles. So, buckle up as we delve into this cosmic tale. Our story begins at the dawn of time, the moment of the Big Bang. Imagine, if you will, a point of infinite density and temperature, a singularity, expanding outwards in a fiery display of raw, untamed energy. As matter and energy intertwine in a cosmic waltz, the universe as we know it starts to take shape. In this early epoch, the universe is a hot, dense soup, a primordial concoction too energetic for atoms to exist. Instead, the universe is filled with a plasma, a state of matter where the heat is so intense that atoms are ripped apart into their constituent particles. It's in this high-energy crucible that the first particles, the elementary particles, are born. Quarks, leptons, and their antiparticles burst into existence from the energy of the Big Bang, a process known as pair production. These particles, the building blocks of matter, are thrown into a maelstrom of energy, colliding and annihilating in a fleeting dance of creation and destruction. But as the universe expands, it also cools. The frenetic energy of the early universe begins to wane, and the conditions allow for the formation of protons and neutrons. These particles, in turn, come together to form the first atomic nuclei in a process known as nucleosynthesis. This moment, the birth of the first particles, is a critical juncture in our cosmic story. It sets the stage for everything that follows, from the formation of atoms to the creation of stars and galaxies. It's the beginning of the complex and beautiful tapestry of matter that makes up our universe. Thus, from the chaos of the Big Bang, the first particles came into existence. From this primordial soup of energy, the elementary particles we know today began to form. Picture an ocean, but instead of water, it's made up of pure, unadulterated energy. Now imagine that energy beginning to cool and condense into something more familiar. Particles. The first to form were quarks and leptons. Quarks are the building blocks of protons and neutrons, which themselves are the heart of every atom. Leptons, on the other hand, include electrons and their more elusive cousins, neutrinos. Quarks came together in threes, bound by the strong nuclear force, one of the four fundamental forces of nature, to create protons and neutrons, but the process wasn't neat or orderly. It was a tumultuous time. Energy was still transforming into matter and vice versa, in line with Einstein's famous equation E equals mc squared. This energetic dance created a perfect storm for the formation of particles and antiparticles, matter and antimatter. But in this cosmic tango, matter won out, leading to the universe as we know it. Meanwhile, leptons, particularly electrons, were doing their own dance. With the electromagnetic force as their guide, they orbited around the newly formed protons and neutrons, forming the first atoms. And let's not forget about the weak nuclear force, the shy sibling in the family of fundamental forces. It played a crucial role in the decay of particles, further shaping the universe's particle landscape. The gravitational force, though weak on the quantum scale, also had a part to play. It may not have had much influence on the formation of these elementary particles, but it would soon assert its power when it came to the formation of stars and galaxies. Elementary particles, the building blocks of all matter, had been born. From a soup of pure energy, the universe had created something tangible, something real. It had set the stage for the formation of everything we see around us today. And all this happened in the blink of a cosmic eye. The universe was alive, and it was just getting started. But the story doesn't end there. There's still a mysterious player on the cosmic stage: dark matter. As we delve deeper into the universe's secrets, we encounter this elusive entity. Dark matter, coined as such because it doesn't interact with light, is believed to make up about 85% of all matter in the universe. Yet it only interacts with gravity. A peculiar trait, wouldn't you say? Now here's where it gets interesting. Dark matter might just be a new type of elementary particle. Unlike the ones we're familiar with, like protons, neutrons, and electrons, this particle is yet to be detected directly. However, its presence is inferred through its effect on other objects. Recently, the James Webb Space Telescope has identified potential dark stars, believed to be the first stars in the universe. These celestial objects are thought to be powered by particles of dark matter, making them up to 10 billion times brighter than our sun. But this doesn't mean we've got dark matter all figured out. It's still a puzzle that scientists around the globe are trying to solve. Could it be made up of gravitons, as quantum gravity suggests? Or is there another explanation waiting to be discovered? Each discovery, each theory brings us one step closer to understanding this cosmic enigma. And who knows? The solution to this mystery could redefine our understanding of the universe and our place within it. Dark matter, a new type of elementary particle, remains an enigma, its secrets yet to be fully unraveled. But rest assured, as we continue to explore the cosmos, we're inching ever closer to the truth. Fast forward to today, and the universe is a grand tapestry woven from these elementary particles. Our journey to understanding the universe brings us to the present day, this fascinating cosmos teeming with life, with planets, stars, galaxies, all come from the very same elementary particles we've been discussing. These particles, in their myriad forms, combine to create atoms, the building blocks of all matter. Imagine the universe as a colossal Lego set, with elementary particles serving as the smallest, most fundamental Lego pieces. Joining together in an array of configurations, they form atoms. These atoms then band together to create molecules, and these molecules in turn form everything we see around us, from the air we breathe to the stars that twinkle in the night sky. But the story doesn't end there. These atoms, under the influence of gravity, gather to form celestial bodies. Some become stars, nuclear furnaces that fuse lighter elements into heavier ones, producing light and heat in the process. These stars cluster to form galaxies, beautiful spirals, and elliptical formations that dot the cosmic landscape. Meanwhile, dark matter, that elusive player in the cosmic drama, continues to influence the formation and evolution of these galaxies. Remember those dark stars that scientists are speculating about? They could be the first evidence of dark matter's tangible impact on the universe, adding another layer to our understanding of this grand tapestry. So the universe as we know it today, with its myriad galaxies, stars, planets, and even life itself, all trace their roots back to these elementary particles. From the smallest quark to the largest galaxy, everything is interconnected in this cosmic ballet. Thus we see that the universe is a grand symphony with elementary particles playing the key notes. So, we've journeyed from the Big Bang to the present day, exploring the formation of elementary particles. We started at the very dawn of time, when the universe was nothing more than a hot, dense singularity. We then witnessed the birth and evolution of elementary particles, from quarks to protons, electrons to neutrons, and the myriad of forces that bind them together. We journeyed through the cosmos and saw how these particles came together to form stars, galaxies, and the vast cosmic web that is our universe. We also delved into the enigmatic world of dark matter, that elusive and invisible substance that makes up about 85% of the matter in the universe. We explored the tantalizing possibility that dark matter could be made up of theoretical particles known as dark stars, or even gravitons, the carriers of gravity. And let's not forget the recent discovery of 3 bright objects that may be supermassive dark stars, potentially providing us with invaluable insights into the nature of dark matter. These discoveries remind us that the universe is still full of mysteries waiting to be uncovered. The story of the universe is a fascinating one, and we have only just begun to understand it. So if you found this journey intriguing, do give us a like, leave a comment about your thoughts, and share this video with others. Let's unravel the mysteries of the universe together.